Hi, this is Leah from OpenIntro. In this video, we will learn how to carry out a hypothesis test for the difference of proportions. The proportion of California residents who reported insufficient rest or sleep during each of the preceding 30 days is 8%, while this proportion is 8.8% for Oregon residents. These data are based on simple random samples of 11,545 California and 4,691 Oregon residents. A. Conduct a hypothesis test to determine if these data provide strong evidence that the rate of sleep deprivation is different for the two states. So in order to provide a framework for this, we're going to use what I've abbreviated the I4c framework. This ICCCC stands for identify, choose, check, calculate, and conclude. And so first we want to identify the hypotheses. And before we do that, let's define P1 to be the true proportion of California residents that are sleep deprived, and P2 to be the true proportion of Oregon residents that are sleep deprived. These are unknown. We're going to make hypotheses about these proportions. The null hypothesis is always that everything's the same. The alternate hypothesis is the thing that we want to see if we have enough evidence for. So the null hypothesis is that the proportions are equal, that the proportion with sleep deprivation is the same, and the alternate hypothesis is that those proportions are not equal. The proportion with sleep deprivation is not the same. And now we're going to choose the appropriate test. We're looking at two proportions, and so we can do the two proportion z-test. Next, we need to check that the conditions for this test are satisfied. We need two independent random samples or two randomly assigned treatments, and we need the success-failure condition to be met. So first, we have two independent random samples here. These samples are taken from distinct states, and so they're independent of each other. And the samples themselves are independent within them because clearly these sample sizes are less than 10% of the population sizes. Now, for the success-failure condition for a hypothesis test, we're going to use the pooled or combined proportion. So let's first calculate that. We want the number of yeses in the first group plus the number of yeses in the second group over the sum of the sample sizes. What you can see is that essentially we're taking a weighted average of these two sample proportions. We get something somewhat between the two of them, and we can see that it's a bit closer to the 8% because the California sample size is larger, so it gets weighted more. So now we have our pooled proportion, and we can plug that along with the sample sizes in and see that yes, each of these terms is greater than or equal to 10. And so with our conditions met, we can move on to calculate. We need the test statistic, which is going to be our point estimate minus the null value divided by SE, or standard error of estimate. So the point estimate, if we look at the null hypothesis, we see that the null hypothesis is saying that the proportions are equal, which is equivalent to saying that P1 minus P2 equals 0. So we're really hypothesizing about the difference. And the null hypothesis is that the difference is 0. Our point estimate for the difference is going to be the difference in sample proportions. And that's the 0.08 minus 0.088. Now the null difference is what we claim under the null hypothesis. And the null hypothesis says that the difference is 0. So that's the null value. And now we need the standard error of the estimate. So the standard error of p hat 1 minus p hat 2. If we're not sure what this is, we can look it up. And what we see here is that when p1 and p2 are assumed to be equal, then we're going to use this form for the standard error. And that's in fact what our hypothesis test is doing. A hypothesis test, we assume H sub O is true. And so we assume here that P1 equals P2 and then proceed. And so because we're assuming P1 equals P2, we're going to use this for the standard error. So notice that this is different than the standard error for the confidence interval when dealing with two proportions, because here we have the P1 and P2 are assumed to be equal. And so we have the combined or the pooled proportion as our best estimate of what they would be equal to. And so we can plug in the pooled proportion that we previously calculated, the 0.0823, along with our sample sizes. And now we have our test statistic. So we can evaluate this. I'm going to use a shortcut on the calculator. Okay, so in order to get this, we're going to go to Stat, over to Tests. We're looking at 2 proportion z-tests. So we're going to go to 2-prop z-test. 2-prop z-test here. We have 2-prop z-test. And now x1 is the number of yeses. So we're going to take 8%, 0.08. We're going to take 8% of the 11,545. And that will tell us how many yeses in the first group. Now that percent, 8%, was rounded, which is why we're not getting an integer. This is a number of people, so of course it has to be an integer. So we're going to call this 924. If you don't put an integer here for x1 and x2, you'll just get a calculator error. Our sample size for group 1, which is California, is 11,545. Our x2 is going to be 0.088, so 8.8% of 4,691. And again, that has to be an integer, so we'll call that 413. And N2 is 4,691. Okay, and our alternate hypothesis is not equal to. This is a two-tailed or two-sided test. And now we're ready to calculate. And so this is how we get our z test statistic, and right below that is our p-value. And here you'll notice this p hat with no subscript. This is the pooled proportion. So the calculator can also report the pooled proportion, 0.0823. Okay, so we recorded these values. Now we're ready for our conclusion. Our p-value is greater than alpha. And so when the p-value is greater than alpha, we do not reject H sub O. And if we do not reject H sub O, we do not have evidence for H sub A. So what are we saying? We're saying we do not have evidence that the proportion with sleep deprivation in California and Oregon is not the same. And you do notice that double negative there, which is fine. Okay, and so now we're ready for part B. Is it possible the conclusion of the test in part A is incorrect? If this is the case, what type of error was made? So let's recall what our conclusion was. Our conclusion was do not reject H sub O. So certainly we could have made an error if we did not reject H sub O when we should have, meaning when H sub O was false. So let's recall our 2 types of errors. We have type 1 error, reject H sub O when H sub O is true, and type 2 error, not rejecting H sub O when H sub O is false. And so in this case, since we did not reject H sub O, if we made an error, we made a type 2 error. That's it for this video. For more free resources, visit OpenIntro.org.